Hey everyone, today we are talking about the theory of the formation of our universe. And we all kind of know this as being the Big Bang. So today we're going to talk about a little bit of evidence for the Big Bang and why scientists support it. And I just have to give a little disclaimer before we get started here, that by no way am I trying to change anybody's personal belief system with this lecture, with these notes. I hope you know that about me at this point in the trimester, that I won't try to do that to anybody. But what I'm giving you is the commonly accepted theory of how most people outside of this school, most people on the planet would think about the formation of our universe. So it's going to be on state tests, it's going to be common knowledge when you leave this place, and I'm responsible for making sure you all have heard these ideas. So again, not trying to change anybody's belief system, just trying to give you information for later. Okay, so here we go. The Big Bang, in a nutshell, is this theory that all of the matter in the entire universe was all squished together in one small area. And because all of this matter was in one spot, it caused this explosion, this bang, big bang of all this material that sent it flying throughout the universe. And that's also why we have this idea of an ever-expanding universe. The universe is consistently, constantly, always expanding. So that means when we look around, we see this movement of stars and objects away from us. And the best analogy I've ever really heard about this ever-expanding universe and the distances always increasing is actually an analogy with bread making. And I know we don't do a lot of bread making anymore, like I don't, but imagine just this idea of making a loaf of bread. And at the beginning, you knead it and you kind of mix it together, and let's say we're even making a raisin bread. So we have raisins in there and we have this nice tight loaf of bread, just dough. And part of it, after you knead the dough, is letting the dough rise. So you put that nice small little ball of dough in a bowl or something and you let it rise over time. And this is something that maybe you've seen happen before. And if you imagine all of those raisins, when you just put that dough in the bowl, the spacing of the raisins is relatively close. But as the dough starts to expand and fill the bowl, the raisins end up moving away from each other, their neighbors. But also at the same time, those raisins are moving away from the center of the dough itself. So we're expanding from the middle of the universe outward, but also the distance between our neighbors is also increasing. And that's the idea of the Big Bang, and that's the idea of an ever-expanding universe. Whenever we have theories, of course, it's going to come with some evidence. And the first piece of evidence we use is the Doppler effect and a redshift. When we look up in space, almost everything we see is showing a redshift. And if you remember from our last video from yesterday, a redshift is just when an object is moving away from the light it's producing and it stretches out that wavelength. And that causes it to shift towards the red side of the spectrum. And the thing that we're talking about shifting are those bright lines. The bright line emission or the dark line spectrum, those are what is shifting here. Okay, so they would just be closer to the red side of the spectrum, whatever those lines might be from the elements. And one really cool thing about this redshift that we see everywhere we look, we can actually measure the amount of redshift and kind of give this idea of a speed at which the universe is expanding. And if we kind of play that in reverse, we can actually imagine, like calculate, how long the universe has been expanding. We can kind of figure out when the birth or the Big Bang actually occurred. And a lot of people a lot smarter than me with a lot bigger supercomputers did the math. And right now the idea, like the age of the universe, is somewhere around 13.8 billion years old. On your notes it says 12 to 14 billion, but I've seen articles and information that's a little more pinpoint nowadays, and it's somewhere around 13.8 billion years old. That's pretty old. So that's when the Big Bang theoretically occurred. Another piece of evidence for the Big Bang is cosmic background radiation. Okay, cosmic background radiation. And what we're talking about here is just the residual, the leftover heat from the Big Bang. if you imagine the Big Bang, everything in the entire universe exploding all at the same time, that had a lot of energy to it, a lot of heat energy in the form of microwave radiation. And when we look around the universe, even right now, everywhere you look has this constant and very weak background radiation, microwave background radiation. And that radiation is the leftover energy from the Big Bang. 13.8 billion years ago, that energy was a lot stronger, but over time it dissipates, it fades because of that expanding universe. And when we look around, we still see that leftover energy today. If you take a cake out of the oven and you put it on the stovetop, is the pan instantly cool? No, of course not. It takes time for that energy to dissipate, to fade. The entire universe explodes all at one time, there's going to be some leftover energy from that, and it takes time for it to dissipate. That's all we have for our notes today. If you have any questions, please make sure to ask. Thanks.